All right, hi, welcome to math class. Here we are again. We're going to compare some ratios. On our test last week, we had a little bit of difficulty comparing ratios, so we're going to try it again. I just kind of want to walk through it so you have some video and some steps to show you how to compare ratios when you run into them again. So sometimes we're asked, how do we put ratios in order? And then we're going to go through the same steps. How do we put them in order? How do we say which one's greatest and which one's least? And how do we say if one is bigger than the other? That all has to do with comparing ratios. So the first question that we're looking at is, how do we put these ratios in order? We have 2 to 3, 6 to 5, and 7 to 9. And we now want to know which order, how we put them in order from least to greatest. So when putting ratios in order, you want to write the ratios as a fraction. And then you want to simplify those fractions. We always want to work with our fractions in simplest form. Once you simplify them, you want to see if the denominators are the same, and then you just simply compare the numerators. However, if the denominators aren't the same, then we're going to have to find the greatest common denominator, make some equivalent fractions, and then compare them to put them in order. So let's start with this first one. We want to say, let's put these ratios in order. The first step is going to be write the ratios as fractions. So we're going to go ahead and write 2 over 3, 6 over 5, and 7 over 9. So now we have 3 fractions that we're going to compare. So we're going to compare fractions. We're going to simplify those fractions. Looking at these 3 fractions, they're all in simplest form, so we cannot make them any smaller. So now we're going to have to go ahead and say, okay, the denominators are all different. In order to compare them, they have to have the same denominator. In order to do that, we have to find the greatest common denominator of 3, 5, and 9. And I know the greatest common denominator of these 3 numbers, one number that all 3 of them will go into, is 45. So we know the denominator we're looking to get these 2 equivalent fractions will be 45. To find equivalent fractions, we just say 3 times what is 45, so 3 times 15 is 45, so we're going to multiply the top also by 15, which gives us 30. So the equivalent fraction here is 30 over 45. On the next one, we're looking at 6/5. We need to get that to 45, and we know that 5 times 9 is 45, so we're going to have to multiply 6 times 9, which is 54. And then our last one is 7/9. We need to get that to 45 on the denominator. So 9 times 5 is 45. We're also going to have to multiply the top. So we're going to do both of these, which is 35/45. Okay, so now we have 3 fractions with the same denominator, and we can just simply take a look at the numerators in order to put them in order. And we can see the smallest or least would be our 2 to 3, this one here. And then we can see that our greatest is this 54/45 or 6 to 5. And then we can also see that 35/45 is our middle. So when we put them in order, they look like this. So it makes it really easy once the denominators are all the same and we're looking at equivalent fractions that way to go ahead and say, all right, let's just compare the numerators and put those in order. We're also asked a lot when comparing ratios, which ratio is greatest? So on our test, it gave us a list of 4 ratios, and it wanted to know which one is the greatest, which is the biggest ratio. So again, when comparing ratios, step 1 is to write those ratios as fractions. You could also convert them to decimals and then just simply compare your decimals. That is another way to do it. So you can do either fractions or decimals. In this case, we're just using fractions. So we're going to write the ratios as fractions. We're going to compare those fractions. And in order to compare fractions, we're going to simplify to make sure we're working with the smallest fractions and see if we can compare at that point. If they have the same denominator, we can. Most often they don't. We're going to have to find the greatest common denominator and make equivalent fractions, and then we can compare the numerators to determine which one is the greatest. Okay, so step 1 is write these ratios as fractions. So we have 9 over 90, and 50 over 40, and 8 30-seconds, and 30 over 9. Step 2 says go ahead and simplify. Let's take a look and see if we can simplify these fractions down. I know 9 over 90, I can divide both the top and bottom by 9, which gives me 1/10. So this fraction becomes 1 over 10. 50 over 40, I can divide both of the top and bottom by 10, which is going to give me 5/4. Go ahead and make this 5/4. 8 over 32, we can simplify that down by dividing by 8. We get 1/4. And then 30 over 9, we're going to simplify that down by dividing by 3, which gives us 10 over 3. Alright, so now we have 4 fractions in the simplest form, and we need to compare those. Again, we could at this point convert these to decimals, and then just simply compare our decimals, or we can go ahead and find the greatest common denominator for these and make equivalent fractions and compare our numerators. So taking a look, 10 and 4, we have 2 that have the same denominator, and you could see right here that we could very quickly say the 5 over 4 is greater than 1/4, so we know that 50/40 is bigger than 8/32. But we need to do that with all 3 of them, so we need to find 4 of them, so we need to find the greatest common denominator for all 4. If it was just the 10 and the 4 and the 4, I'd say 40, but 3 doesn't go into that, so let's take a look at 60. All of these can use 60 as the greatest common denominator. Oops, my pen's off the board. There we go. Okay, so again, we're just going to make equivalent fractions. 10 times 6 is 60, so we've got to do the top. Makes 6/60. This one here, 4 times 15 is 60, so I know I have to multiply 5 times 15, which is 75. One-fourth, we're going to say that's multiplied by 15, so we also have to multiply the top by 15, which gives us 15 over 60. And then the 10/3, let's see, 3 multiplied by 20 to get us 60, so you have to multiply the 10 by 20, which gives us 200. So this one is 200 over 60. Okay, so now that I have all the same denominators, I can just simply compare those numerators to determine which one is the greatest. And based on the numerators here, I can say this 200 is the largest, which was 30 to 9 was my greatest ratio here. Alright, so we see how to figure out which is the greatest ratio. Along with that, we also need to say, okay, which ratio is greater than 2 to 5? So now they're giving me a particular ratio and asking me which one of these is bigger than that 2 to 5, which is the greater, which one is greater than 2 to 5. This is simply comparing ratios again, so we're going to follow the same steps, write the ratios as fractions, and then we're going to compare fractions, and we do that first by simplifying and then seeing if we can compare, and then finding the greatest common denominator and making equivalent fractions and comparing those numerators. So let's start with step 1. Step 1 says write these ratios as a fraction. Remember that we have 2 to 5 and we're comparing it to each one of these. So we want to just start with 3/8. We're going to go ahead and put 3/8 as a fraction, and remember we're comparing it to 2/5. We want to know which one's bigger. Looking at 3/8 and 2/5, I can go ahead and find a common denominator of 40. 8 goes into 40, that's times 5. So we're going to multiply the top 3 times 5, which is 15. So we're looking at 15/40ths. And then we're going to make this one greatest common denominator 40. We're looking at multiplying it by 8. By 8, that gives us 16/40ths. So when I'm looking at 3/8 and 2/5, I can see that 2/5 is greater. So we're going to have to do the same thing for 9/20. 9 over 20. Write it in fraction form, and we're looking at 2 to 5 write it in fraction form. So I can also see that a greatest common denominator of 20 and 5 is going to be 20. So this is going to stay 9/20ths. 9/20ths. And then this one, to make 2/5 equivalent to the 20ths, we're going to multiply it by 4. Whatever I do to the bottom, I have to do the top. So this one has 8/20ths. So I can see here that 9/20ths is indeed bigger than my 2 to 5. Alright, so we're going to go on with the next one just in case, just so we can check and make sure, because we already know that 9/20ths is greater than 2/5, but we know the first one's not. Let's look at 4/15ths. Write it as a fraction, and we're comparing it to 2 to 5. Again, I can see the greatest common denominator between these two numbers will be 15. This one stays the same, so we have 4 over 15, and we're looking at getting this to 15. That's times 3. Multiply the top times 3, 6/15. 6/15. So we know 6/15 is greater than 4/15. So 4/15 is less than 2 to 5. 2 to 5 is greater. Alright, so that is not a ratio that is greater than 2 to 5. And let's do the last one, 7 over 25. And we're looking at 2/5. Again, you could also convert these to decimals and just compare the decimals. 25 and 5, we know that that's going to be the greatest common denominator, so 7/25 is going to stay. We're going to make this one equivalent to 25 so we can compare. That would be times 5, so that would be 2 times 5, which gives us 10. And the 2/5 is equivalent to 10/25, which is greater. So the only one that is greater than 2/5 is the 9/20. So we know that that would be our answer after we've compared all the ratios. Okay, so just for your notes, I want you to remember that sometimes somebody will ask you which ratio is the greatest, and they want you to compare ratios, or you'll be asked to see if one ratio is greater or less than the other, and you'll be needing to compare ratios. Or they can ask you to put the ratios in some type of order from least to greatest or greatest to least, and again that would be a comparison of ratios. And in order to compare ratios, you want to write the ratios as a fraction and then compare your fractions, simplify, see if you can compare, find the greatest common denominator and make equivalent fractions, and then you would go ahead and compare your numerators. Remember that you could also convert to decimals. So this would be or convert to decimals and compare. So either way will allow you to compare ratios. All right. That's all for today, so make sure you copy your notes so that you know how to compare ratios, and we'll see you in math class.